And okay, I guess I'll start now. Hopefully, there's a couple more students who will join soon. And this week, we're gonna cover markers and channels. And before that, we just do a quick review of what we did last week. So if you remember, and last week we first talked about the analysis framework. It's actually quite simple. And did anyone remember what does the analysis framework is? Anyone? So, okay. So there are three things in the analysis framework. Anyone? Still no one? Okay. And so these are the and what, why, and how. So that's three main parts. And so you've probably seen this figure before. We have shown that a few times now. And so, and the what is shown, that's about the data. So the types of data, the types of attributes, types of dataset, etc. And the why is the user task and why the user want to look at the visualization, or why do they want to do visualization at all. And finally is the how. So how is basically how do you design the visualization so it can show the type of data and to support the type of task that user wants. Okay, and so we covered the what. So these are many different types. So we start with data set type, and there's this data type. Sorry, we start with data type, and then data set type, and finally we talk about different attribute type. And this is what we covered last week. So we covered the why. So it gives you kind of abstraction of different types of tasks people may do. So these tasks are related to the action and targets. So the action is, I guess it's action required in the analysis. Excuse me. And target is the things you are looking for in your analysis. So in terms of actions, we mentioned there are like kind of three levels. And at the top level, you always have analyze. And the middle level is the search. And the bottom level is the query. So for the analyze, you can either consume the visualization or produce something new, add to the visualization. And in terms of consume, you can either discover, present, or enjoy. Anyone remembers the difference between discover, present, and enjoy? No? Everyone is very quiet today. And so discover is finding something, and this is what we be using visualization mostly for. And presentation or present is when you want to show the results to someone else. So in a sense, you already know the answer, you just want to show other people what the answer is, and sometimes how do you get to the answer. And finally, we have enjoy. Essentially, it just means you didn't really do this for work. It's just something you're interested in, you want to explore. So you may remember the examples we had for the enjoy is this, they call it name Voyager, which essentially shows the popularity of names over time. And that's not really for any, say, business or any more serious research purpose. It's just something people might be interested in. And we spend relatively less time on the produce. And here you are producing something new that was not in the data before. So you can create annotations. For example, you can have a label or add pointing or annotation pointing to certain points in the visualization, like this one here. And you can record, which you can record, say, a screenshot or even a video recording of the entire analysis session. And you can have derive. So derive, again, is deriving something a new attributes, for example, from the data you have. So the examples we had last week, so you can maybe in your data, you have the import and export values of a country. And then you can derive a new attributes, which is difference between the two. So that's either be the trade deficit or trade deficit between the so that's the difference between the import and export. So that's the derive a new attributes that was not in the data before. And then we also talk about the search. So and once you picked a certain type of analysis, then you always involve certain type of searches. Essentially, search is the part you're looking for the answers from the visualization. And then there are two main kind of aspects of the search, and whether you know what you're looking for, and then the other one is whether you know where the target is in the visualization. And so it depends on whether you know the target or not, and when you know the location of the target, and you have these four different types of search. So this one, which is called lookup, is probably the easiest because you know the target, and you also know where the target is, so that you can probably locate the target quite quickly. So that's called lookup. And then this one, at the other end, where you don't know the target and you don't know the location of the target, and that's probably the most difficult one or takes the longest time, then that particular type is called explore. And then you have also the other two type where it's the browse and the locate. Okay. And finally, and we have at the bottom level is a query. So this is kind of talking about so what you need to do about the target. So you're searching for the target here, and once you find target, you might do identify in the case, for example, you just want to find outlier or the data points with minimum or maximum values. So that's called identify. And you can, I don't know, and you can also do compare. So in this case, you don't have a single target, you might have multiple ones. And in this example, so what you're looking for is not just a single point, but actually lines. You have two lines, and you can do a comparison between the lines. And finally, we have a summarize. So in this case, you have even more targets you're looking for, and you're not usually not looking at a specific single target, but maybe everything in the data set. Okay, and then in terms, once you find the target and the things you're looking for could be, if what you're looking for is and more than one target, then what you can do is look at it, say, the trend or an outlier. So an outlier cannot exist by itself. So only if you have these other groups of points in the data set, which has a different pattern compared to this one, and then that one itself becomes the outlier. So just by one point itself, without any context, it's not possible to tell if it's outlier or not. And then finally, we have the features. Features is kind of a more general term for anything that's not the trends or outliers. You can include it as features. Okay, and so if you're looking at particularly attributes in the data, if it's only involve one attribute, and you can look at the distribution of the data, sorry, the distribution of the attributes or the extreme values of the attributes. So these are two possible attributes. And if you have many attributes you want to look at, and then you might look at dependency, correlation, or similarity. So visually, they might be similar, but there's some differences, especially between dependency and correlation. So dependency usually means one of the variables, it changes, depends on the change of the other variables. Whereas correlations, and it just says two attributes, they are say change always in a similar way, but does not necessarily means the change in the one affects the other. So that's the difference between these two. Okay, and yeah, so we can also have some other type specific and targets. So these ones, for example, the topologies or the specific example called the paths only exist in network data. So you can see if the points or part of the graph or network is connected to another. So this is something special to network data. And for spatial data, which is essentially mostly maps, and you can also discover different shapes, what kind of area look like, how big they are, etc. And yeah, again, these things are quite abstract. I think we provided some examples last week. Hopefully, can help you understand a bit better. And then later on, when we do the exercise, will hopefully make more sense. So during the exercise, you need to identify what kind of actions or targets you have for your realization. Okay. And so from this week on, we're going to talk about the how. So we covered what. Why so slow? We covered the what, why, and then so these are the two parts, and the final part is the how. So this is where you actually design your validation. So the criteria of a good design, or what you should really do, is based on the information about why and what to make sure the visualization you design match the data set and match the tasks the user want to do or the type of analysis user want to do. Okay. And so I'm going to start with something called marks and channels. So these are like two basic elements for the visualization. You're going to cover what they are, different types, and their effectiveness in terms of what kind of data they are good to represent or for what type of analysis. So for different what and different why. So when to choose different markers and channels. Okay, and before we talk about marker and channels, I just want to introduce another term. It's called visual encoding. And essentially what it means is maps data and to graphics. So the data could be different, depends on the type of data, could be numbers, could be categorical. And the graphics, there will be the things you can see visually. So you can represent the data as length, as position, as color and shape, and so on. And so in short, and visual encoding means map attributes into graphical elements. So you can have quantitative attributes, for example, the amount of sales in the supermarket data, and to the length, which is a graphic element. And for example, for the categorical data, such as the type of product or category of the product, and you can map to the x coordinates, the position. So, and this will be the example. So we have example. So this is a simple bar chart and showing the sales of different products. And then you can see the y or the length of these bar maps to the sales, and the x positions maps to the types of the product or the category of the product. So that's what we call visual encoding. Okay, and so another terms we're going to mention a lot is called alternative visual mapping. So once you have the data, for example, product and product and sales, and there are many different ways to create the visualization. So there's not only just one way to do this. And these are called alternative visual mappings. And so, for example, using the similar data, we can map something to the y coordinates, but instead of using a bar, we are using dot to represent each product. That's entirely fine. So here we have 3 dots, and it shows exactly the same, very similar information, but instead of bars, we're using dots. So that's an alternative visual mapping compared to this one. And one thing you can potentially do with this kind of scatter plot visualization, you can encode extra information. For example, you can use color to indicate the type of product. So here, the red one represents furniture, and the blue one represents an IT products. And in theory, you can do this with a bar chart as well. Okay, and you can even have one more attributes in this sense, and you can use the size of the circle to represent another attribute, for example, the profit of different categories. Okay, so just to quick recap, so you can have different, so the visual encoding is how do you map the data onto a graphics. As we can see, there are many different ways, and each of them is alternative visual mapping. Some of them better than the others, and depends on how you design, and you can add lots of different, you can add more than one attributes, 2, 3, or even 4 into one visualization. And we're going to talk a little bit more about what will be the best effective way to do this a little bit later. Okay, and then we're going to come back to this concept of markers and channels. So we talk about graphics essentially is how you can potentially represent data as visualization, but the visualization itself is just made up of markers and channels. And so a marker is a basic graphical element in an image, and it's a geometric primitives. And so you can also think of a marker is like an items in a, say, table dataset. And so you would have, say, if you remember, does anyone remember the table dataset? And which has the items and attributes. So if I could go back, maybe go back here. Yeah. So you can see this is my table dataset, and it is made up of the items, which in this case is the rows, and attributes, which is represented as the columns. And so you can think of marker is representing the items, and the channels is representing the attributes. Okay, let's go back there. So marker is a basic element. Okay, and you can have different types of markers, and you can classify them based on the number of dimensions. And so you obviously has a dot or point, and so these are 0-dimension marks in the sense the point itself doesn't have any size, so it only has a location but not size, so it's a point, and we call these 0D marks. And you can have 1D marks, which has only one dimension, so these are the lines. Okay, and can anyone have a guess what, say, 2D marks are like? Hello? Oh,
The area of something, maybe?
yes, exactly. So, and the 2D dimension will be actually just called area. And because this area can potentially have different shapes and sizes. And finally, you're going to have a 3D mark. So these are like the 3D shapes, like a cube or sphere. And these are rare. And we're going to explain why that's the case a little bit later on. Okay, and so we said the marks is like the items in your table, and the channels is used to represent attributes. So let's say the marks is represent different products in this store, and the channels will represent different attributes of your product, like the price, the profit, maybe the size, the weight, etc. So these are the channels. And so from a visual perspective, and the channels decides or controls the appearance of the mark, and is independent of the mark dimensionality. So it doesn't matter whether it's 1D, 2D, or 3D marks, and you can have the same channels. Okay, so one possible channel is the position. So you can have vertical position of your mark, in this case, which is a point, horizontal position or vertical position, or use both. So in many cases, you can use a horizontal channel to represent one attribute, for example, sales, vertical channel or vertical position at the second channel to represent another attribute, for example, profit. And then you use these two channels, you can represent two attributes. And you can use color. So for example, this one here. And so what is the mark here? Anyone? Does anyone know what is the mark here? Okay, and then if I do a multiple choice, say, is the marker here a point, line, or area? Um,
Point?
okay,
No, I don't know.
okay, and maybe I do like a quick poll now. So say, if you think this for this one here, the visualization here, the mark is a point. Please click yes now. Okay, so that means no one thinks this is point. And oh, we have one. So Amima, you think this is point? The mark here is point. Do you want to expand on
Yeah.
that?
Sorry. Are you talking about the color one or all of them?
Just the color one.
Um. So like the mark would be like, yeah, maybe yeah, I'm not too sure.
And so the mark is the kind of the visual element which represents an individual items from the data collection.
Yeah.
Uh, so okay, so you think it might be point here. Okay,
Yeah.
Chidu also think that's point. Okay. And so how many of you think and the mark here is a line.
Line. Oh, sorry. Yeah.
So okay, I have Roya.
Yeah.
Anyone else? Can you click yes? Okay,
Okay.
Liban.
Line. Yes.
Yeah,
Line.
Lakshina. Think it's line. Oh, now everyone think it's line except Roya. Except Amima. Okay, and if I clear that one now, so is there anyone think the mark here is a shape, which is a 2D marker? Okay, so that means no one. Yes, and so the correct answer is line, and maybe I can just go back very quickly. So in the previous slide, we can see we have these three, actually four types, but we only show three here. The points, which each dot or point represents an item. You can have a line to represent an item as well. It doesn't have to be a dot. It doesn't have to be straight line either, it can be curly lines. And finally, you have the area. So it does not only has length, but also has width as well. And you can form shapes. And so in this particular example, we can see we have 3 elements or 3 items, and each line represents 1 item. So the mark itself will be a line, even though they are not straight. Okay, so we are talking about channels here. So it uses the color of the line to represent something, for example, different product categories. Okay, and another potential channels you can change is shape. For example, you can have different shapes for your, how do I say, mark. So you can have a triangle shape, double cross or star shape, a line, or some arbitrary shapes. Okay, can I ask again? So what is the mark here? So again, we have the same options. We can have the point, line, shape, or 3D one. Obviously, this doesn't look quite 3D. And so how many of you would think this is point? Can you click yes now if you think it's point? Okay, so it means no one. And so how many people think it's line here or 2D, a 2D mark, let's say, a more general one, a 2D mark? Okay, I have 3 people, Roya, Chitu, and Lakshan. I think this is 2D mark, which is a line. And so how many think this is a, sorry, 1D mark, which is a line, 2D mark, which is an area, or anyone think this is a 2D mark? Ah, nobody. There's a couple people who.
No, I don't think it was a line. You said that if it's a 2D shape, we said yes.
Ah, sorry.
No, not a line. No, I don't think.
No.
Maybe
Sorry.
one of them.
Yes. Okay. Okay, so maybe I can ask again. So, and just say how many people think this is a 2D mark, which is a shape? Okay, yeah. So I think the majority of people think this is 2D shape, which is correct because you need and both the x or y dimension or the width and height to represent different shapes. So it has to be a 2D mark. So I hope that makes sense.
What shape? Sorry, question here. What shape are we talking about? Yeah, is it the triangle or the asterisk or which one of them exactly are we talking about?
Just to say here, so first we know each of these individual shape is a mark. So essentially, this represents 1 items from your data. Like say, this is product 1, this is product 2,
Okay.
this is 3rd, and this is 4th one. And then when we talk about in terms of the mark itself, in the previous slides, so you can represent each mark as a 0D, which is point, or 1D, which is line, or 2D is areas. So the main difference here is being, say, if it's point, then the mark cannot have, say, width or height, because that's 0 dimension. And for lines, you can have only 1 dimension, which is the length. You can treat it at either as width or height, but for areas, you can have 2 dimensions, so both x and y, or width and height. And in this particular case, if I can get to the next slide. And this case here, to be able to see different shapes, we need both the x and y, or the width and height, so then we can see these are different shapes. If we don't have size or only have length, we will not be able to see these are different shapes. And so that's why we say it's a 2D mark or area mark. Okay, and back to the channels. And finally, we can have tilt. Then let's say this is your mark. In this case, will be a 1D mark, which is a line. And then you can see that you can use the angles between the line and say horizontal to indicate some values. And maybe this is when you have the maximum value, and this is when you have 0, and this will be somewhere in between. Yeah. So yeah, maybe just go through this quickly. And so the channels controls or affects the appearance of the mark. For example, if it's tilt, and it will shows kind of the direction of the mark, which is the line. If here can be the color, so it decides if you use a channel as a color, then it will defines the color of the mark. And also, it's independent of mark's dimensionality. And so, for example, maybe this will be easier to explain. So it doesn't matter whether you are a 0D mark, which is the point, 1D mark, which is a line, or 2D mark, which is a shape. You can always have horizontal and vertical positions. Does that make sense? So these two channels are independent of the mark dimensionality. Doesn't matter whether it's 0, 1, 2, or even 3D. You can always have these channels. And also color is the same. And doesn't matter whether you are a dot, a line, or shape. And you can always have colors. Okay, and then shape is a bit different. So you can't really have a shape if you are just a dot point or just a single line. This one has to be 2D. That's a slightly unique case. And for tilt, it's also a bit different. And again, you can't really have a tilt if it's a point. And for the shape, it might not be that obvious, but for line, that's probably most obvious ones. Does that make sense? Or okay, and so actually, design and visualization may be one of the most important things you do in creating any visualization, and is to choose the mark for the items in your data set, and then choose the channels you want to show the attributes for. So that's kind of like a slightly oversimplified, but that's the essence of the visualization. To choose the correct mark and the visualization and sorry, channel. That's all you need to do. Okay. And obviously you can also have one last one. You can also use size of your mark to represent something. And as we mentioned, for the 1D mark, you can't have any width or length. So you can't have size, but for 1D mark, you have length. And 2D marks, you can have area. And 3D marks, you can have volume to represent certain things. Okay. Let me hide this. Okay. Okay. And oops. Is this the? Okay. As I mentioned before, when you create a visualization, you are essentially creating or visual encoding, which is about marking or mapping from what you have in the data, which are the items and attributes, to the visual elements, which is essentially the marks and channel. So we said before, so the items would map to the mark. Each mark represents one item, and the attributes map to the channel. So each channel represents one attribute. Okay, so maybe let's do this and go through these examples. Okay, what we seen this example before, a very simple bar chart. And so each bar represents a product, and the height of the bar represents sales. Okay, And so the first question is, and what is the mark here? Anyone?
A line.
A line. Okay, very good. Anyone else? Anyone think this is the point? Or probably not. Anyone think this might be a shape? Oh, also no. Does anyone want to click yes if you think the mark here might be a shape? Oh. Oh no. Okay. That's slightly surprising. And usually I would have a few people think this might be a shape because this looks like a rectangle. But in this case, because we're only using the length of the mark to represent something, and the width of the mark does not represent anything. So we'll just call this line. And okay, so next we're going to look at the channels. Can someone tell me what are the channels used here and what attributes does a channel represent? Does that question make any sense? And so the channels are the things we mentioned here before, like position, color, shape, size, etc. And so the question would be, what channels are used in this validation? That's the first one. And then what attributes they are representing? So the attributes is the one you actually from the data.
I think here the position is specified.
Okay, position, yeah, that's correct.
Yeah.
But
what?
So the position, are you talking about X position, Y position, because it's 2D, or both?
No, I mean, from the dots you can, no, I just know that it shows the position, but it's vertical and horizontal. Vertical and horizontal position is shown, I think.
Yeah? Yes, you mean the position along the X-axis or the Y-axis, or? So you can have, because this is 2D, you can have potentially two positions, just as we've seen in the previous slides. And you can use horizontal position or the vertical position.
So it's vertical, yeah.
You think here the vertical position?
But where? Which one? Sorry.
This one, this first one.
Yeah, vertical.
Vertical position. So that means this along this line, y-axis.
Yeah.
Okay. And what does that represent?
Which one? Sorry.
And you said this is one of the channels used, right? We're talking about these channels here. And what does it represent? What attributes does it represent?
Sales.
Sales. Yeah. Okay.
Can we say it actually can go in two ways there? We have sales and products. Sales being the vertical position, and product being the horizontal position.
Yes, I think that's quite close. And so here we're using two channels, as I said, and the vertical channel is to represent the amount of sales, and the horizontal position is to represent different products.
Categories, right?
Yeah.
Okay.
Or category. And there's slightly difference, just says here, and the sales itself is a quantitative attribute, if you remember. So these are the numbers, and the horizontal one is a categorical attribute. And so these essentially just means apples, milk, bread. So something you know they are different, but you can't really do any computation or you can order them in some way. Yeah.
Yeah.
Okay. I think we happy with this now, and let's go to the next one again. And the first question is, what is the mark? Anyone?
Point, definitely. Yeah.
Yeah, point. So
Yeah.
essentially have 3 points or dots representing 3 items. Yeah, so that's fine. And the next question is, okay, and what are the channels? So it's slightly different. It didn't tell you what channels are, but can you see what are the channels of these mark are used to represent data?
Both vertical and horizontal.
Yeah, I think Tommy said it's vertical and horizontal positions. Yeah, so it's the same. So essentially, each of these mark and the position would represent something, even though they didn't quite say in the validation what they represent, which they should. But basically, that's the 2 channels. You can use that to represent 2 attributes about each of these data item. Okay, and if we look at this third one, so the difference is now for each dot, you can have color as well, and the color represents whether it's furniture or IT product. Okay, and so here it doesn't change in terms of mark, it's still point. And in terms of channel, so what are the channels here now? Anyone?
Same as the last one.
Okay.
Yeah, because they are shown in a horizontal and vertical position, so it can be both.
Yes. Okay, and so I think both Roy and Tommy said, okay, same as before. We use the horizontal and vertical position as 2 channels to show. And is any more or any difference in this case? Anyone? No.
The
So
color,
here we
They,
can. Sorry.
they are
Col-
represented with different colors, as you said, because it might be a IT.
That's right.
Yeah, so that's why, yeah, they are represented. I mean, they are colored differently, so someone can realize which one is furniture, which one is IT.
That's right. So here, essentially, we have one more channel, which is the color itself. And this is used to represent the type of the product. This is a new channel which was not used here. So we have the vertical and horizontal position represent something, and we have a new channel which is color here, used to present a third attribute, which is the type of the product or category. Okay, and can we do the one last one? And so what is the mark here?
point.
Point. Anyone else? Okay, and so I guess we all agree it's point, but I'm gonna come back to that, why it might not be a point. Actually, I write point there as well. And then let's look at the channels. So I think compared to this one here, and the difference is these circles or dots now, or point, now have different sizes as well. And so obviously we still have the vertical, horizontal position and color, right? But also the sizes changes as well now. And so what are the channels in this validation? Anyone?
Same as the last one, plus
Hello.
size.
Yeah, okay, yeah, I think you're starting to get that now. Yeah, so we all still have all the vertical, horizontal position and color, but also we had a new one, which is the size of these circles, which can be used to represent a new attribute of your data. Okay, and then because of this, because we are using the, say, the width or the radius of the circles, and that make itself no longer a point, if that makes sense. So If you
Sorry,
remember,
say it again, please.
because each of these mark now have a size, right? Because we're using size to represent
Yeah.
some values, maybe say the, I don't know, the sales of the product or the profit of the product. And they are no longer a point because if you look at before, you can find it. Okay, and when we define the point, it's a 0-dimension mark, which
Yeah.
in a sense, it cannot have any width or height. So it does not have size. You can either only have a point or not having point.
Okay.
So when you, and this is fine previously,
Mm.
and for these two, and the size of the dot or point does not represent anything, so it's okay. Whether you have, so you don't need to change the size. Whereas in this particular case, and you can see we need to use the size of the mark to represent something, and that becomes a two. In this particular case, you probably would treat it more like a circle, and that becomes an area mark or 2D
Oh.
mark.
Okay.
Yeah.
Yeah. Go.
Mm.
Hi, can I
Oh.
ask a question?
Yeah.
Does that mean you've added another attribute then? Because if you've got sales and products, and then you said it might be something like markup or something like that.
Mm-hmm.
Does that mean you've added a third thing, like profit?
Yes. So I think, for example, 2 attributes here, because we only use 2 channels, 2 channel here, are slightly different representations, so that changed the mark from line to point. And here we add a third attribute, then you need a third channel to represent it. And this one, add 1 more compared to this one.
Oh, sorry, so a fourth attribute, yeah.
Yes, so that's the fourth one then that needs a new channel to represent it.
Mm-hmm.
So essentially, the number of attributes you want to represent in the validation have to match the number of channels you are used in the validation.
Okay, thanks.
Yeah, hope that makes sense. And then you can easily see you can't just do this infinitely. You can't say I have 100 attributes I want to present, but it's quite difficult to come up with 100 different potential channels you can use. I think 5 will be fine, but 100 might be difficult. Okay, and so we now covered the markers and the channels, and we discussed what they are, and then we're gonna briefly talk about their types now. So let me see. Okay, we'll give them 2 types, and one is called identity types. So these are the channels, so like the size, length, position, color, etc. And the identity channels is for categorical attributes. So, and basically you can only say whether they are similar or different value, but you cannot say order or do some computation among them. So product category is an example of this. And then the channels that can be used to represent categorical attributes is called identity channels. And for example, you can use shape or color to represent identity or different types of product, for example. So these are called identity channels, basically channels for categorical attributes. Okay. And then you have magnitude channels, you probably already guessed. So these are the ones used to represent quantitative attributes. So quantitative usually just means numbers. You can use that. So you can use size or position to represent quantitative attributes. So these are called the magnitude channels. So you can use position, either horizontal or vertical, or you both. You can represent 2 of these attributes or the size, either in 2D, sorry, 1D, 2D, or 3D, amount of tilt to represent. Okay. So it is not like the when we talk about different types of attributes, we have very clear distinction and differences. Let me see. I can find the previous one I can jump to. Okay, and if you remember, when we're talking about attributes, we can have categorical and then ordered. And then within the ordered, we can have further breakup of ordinal and quantitative. Okay, and it's slightly different when you talk about the channels. So in theory, you can use any channel to represent categorical value, or use any channel to represent ordered or quantitative. It's just they will not be as effective. The effectiveness will not be the same. And so, for example, yeah, okay, let's say maybe the shape and colors are good ones to represent categorical values, right? But say it doesn't say it's not possible, for example, use the tilt to represent categorical value. And you can say, okay, this position means type 1, this position means type 2, type 3, and type 4. It's still possible, but might not be as effective using shape or color. Does that make sense? And the other way is also true. For example, color may be good at represent different types, but you can also say, okay, I really want to use color to represent my numbers. I say this black is 1, red is 2, and green is 3. That's also possible, but it just say does not quite match how we understand. And so it might not be as effective as say using positions or lengths. Yeah, so that's a quite important distinction. Okay, so this actually leads out onto next part, is we talk about the effectiveness of different markers and channels, actually mostly channels. Okay. So on this one, this is probably one of the most important thing, not just for this lecture, but maybe for the entire module. And so do hope you can pay a bit more attention. So on the left-hand side, we list the different channels that can be used to represent ordered attributes. So these are like a size or numbers. And on the right-hand side, we list the different channels can be used to represent categorical attributes. These are like a product type. And also these channels, for example, position, uncommon scale, length, or area, and all these ones are ordered from the most effective one to the least effective one. And so the position on the common scale is above length. So that means this is more effective to show a ordered attributes compared to length. So the same works here. So these are all the attributes that you can use to represent different categories or data types. And then the ones on top is more effective than the one below. So the spatial region is more effective than color, then more effective than motion, and finally more effective than shape. So the shape is probably the least effective ones. Is any questions so far? Okay, so I'll try to go not too fast because this is an important part. So you know this different attributes so different channels can be used to represent ordered attributes or just maybe even just numbers. And there's different channels can be used to represent different categorical attributes or types. And this is the order, how they are, how effective they are. So if we look at this one, and so the most effective one is called the position on the common scale. In the sense, and these two positions, they start at the same point as the common scale. And then the second most effective one is position on unaligned scales. So these are still positions, but the start point is different. So for example, if you want to compare, it'll be a bit more difficult and relatively to this one. And then you can compare the lens. Sorry, you can use the lens to represent an ordered attributes like numbers, but this is less effective compared to these two. And then this tilt and angle, again, you can use that to represent, but it's actually more accurate or effective compared than the size. Okay, and then even less accurate or effective is the depth. So you can't really see here, but depth, what is really meant here is it's used the how far away the items is from the viewer as a third dimension. So x and y will be on the flat surface next to the user, and this is how far away from the user to represent some value. That's not very good. And this one says color luminance, and so that just basically means grayscale. And the color saturation, that means how kind of the amount of color. So this is very red. You can use that to represent a large value. And this is a very light red. Use it to represent a small value. So these two are about the same effectiveness, but on the overall scale, they are not very good. And finally, you can use curvature to represent the amount of value. So maybe say this is 0, this is 1, this is 2, and this is 3. Okay, it's possible. And its effectiveness or accuracy is similar to use 3D size. And these are probably the least effective ones among all the ones listed here. Okay, and we have similar situation on this side. And the first one is a spatial region. So what it means is if you have different types, the most effective way to show the types is if you group all the items belong to the same type together. That's the most effective ways. So imagine you have one group here, another group here, and maybe a third group here of different items. Each group have lots of different items inside. This will be the most effective ways to show different types or categories. The next most effective way is to use color. So you can say the yellow color is type 1, red is type 2, and this green or teal color is type 3, and blue one is type 4. Okay, that's still okay. And the next one is say motion. So this is something a little bit trickier in a sense. So you can do easily say using, say I have two types. One type are all the points which does not move. And the second type is everything that moves. And I can use that to show two different types. And it's actually also possible. Say we have one type which doesn't move, and the second type I move, say, in circles, and then a third type I move in a different way, for example, back and forth in a line. And you can also use that to represent different types. And finally, you can use shape to represent different types. And that's the least effective. Okay, any question or? Okay. Okay. So for this part,
just one question with regards to motion. How do we go about representing that? And can you give us like an example on how we can go about representing that, the motion one?
So okay. So if we just say representing, for example, and each dot is represent a student or person, and then I say the female are the points which does not move, and all the points that moves has a motion is male. So then you can see which points represent female and which points represents male. Is this the kind of examples you?
Yeah. Yes.
Yeah.
Yeah. But with regards to trying to actually dig deeper, why is the female, why is that stationary, and why is the male moving? Why would you say that? I mean, I'm trying to actually visualize, where you can, or how you can actually interpret that, with the example you have just given.
No, I mean whether the moving dots is male or represents male or female, and is completely up to you. You can decide, and that itself does not affect how easily people to find out whether a person is male or female. So if you tell people all the non-moving points are female, and people can, and if you tell people all the moving points are female, and the accuracy people can identify female will be the same. If that makes sense.
Okay. Yeah.
Okay.
Yeah.
Or let's say if I say I use red to represent female and blue to represent male, and most people can identify the gender quite easily. But if I swap them, I say, and the red is male and the blue is female, people still should be able to identify the genders equally accurately. So the only difference comes with, okay, if you use color to represent gender, or do you use motion to represent gender, and then the people's performance will have a difference.
Okay.
I think that's a very important point. So basically, that means all these, for example, can be used to represent gender. And if you say put all the female in a group and all the male in another group, this will be the easiest for people to identify the gender. And you can use two colors. That will still work, but probably not as as good as, say, having one group which are all male and one group is all female. And similarly, you can use, say, moving points to represent one gender and non-moving represent the other. It will still work, but again, further, not as good as color. And you can use shape. That will be the least effective.
Okay. All right. Thank you.
Yeah. Okay. Okay. And so essentially, when you create a validation, and your job is really just to pick an attribute from the data that you want to show, and then pick a channels that will be used to represent the attribute visually. That's all it is, really. So what you want to do is, and you always want to pick the channels that is most effective for the attribute. Okay, and for example, if I want to represent the price of my product, then I know price is a quantitative attribute or numerical attribute. So I should looking for something from this side. Yeah. And then among all these channels, and this one is the one on top. So I should use this one to represent my price. So that will be the most effective representation. Does that make sense? Can I see a vote in your participant list? If you think that makes sense, please. Yeah. Okay. Please click yes. Okay. So for most, that's fine. Okay. And then if you have two attributes to encode, and then you should pick the next most next available highest ranked channels. Okay, so for example, I have price, or I already decided I'm going to use position to represent my price, and then I have to, but I also have another one, which is the profit. I also want to show. Then in that case, so first I cannot use this one, or at least I cannot use this one along the x-axis, if that makes sense. If that's already used for the, what was the first one? The price. So the profit, I could potentially using lens, or I could still use the position on the same scale, but in this time I can have to use y-axis instead of x-axis. If that makes sense. And it goes on. And so if you have third ordered attributes or numerical attributes, because you already used x and y position, so you can't use this anymore. And you can't also use this one because you already used the position of the node. Then you might have to consider here, which is the length of your mark. So you might want to use the mark, so the length of the mark, and to show, so you can have an XY position, but instead of each point, it will be a line, and the length of that line represents your third number or quantitative attribute. Okay. And then see expressive, yeah. So obviously, and you want to match the type of channel with the type of the attribute. So that just says, if you have a quantitative attributes, you look on this side, and if you have categorical attributes, you look on this side. So you try to say for categorical attributes, you want to avoid anything on this side. And even for the quantitative attributes, you probably want to avoid the ones at the bottom anyway. They are not very expressive, are not very effective. Okay. And then we're going to talk a little bit about actually, how do you know which one is good? So I told you, say, these ones are good for numbers and this one good for types. And this is the most good, this is the best one for numbers. And this is the least or the worst one for numbers. But how did that come from? Yeah. So people actually have done studies and to try to show this. Okay, so they measure the accuracy. So basically say how accurate the visual representation can show the values. For example, if it's a number. And the issue with human is we actually see different visual channels differently. Okay. And this is actually something quite interesting. And so this is again a line chart. On the axis, it represents physical intensity. So that means, for example, if you use the brightness of the color to represent, so further going that way, that means brighter, and further going to the left is less bright. And if you're doing lens, so if you're going to the right, that means longer, and if you're going to the left, it means shorter. That's what physical intensity means. Yeah. And this side represents perceived sensation, or more like a perceived value. So in general, you can see most of these lines and start from the bottom left and going upwards towards the right. So that means as the physical intensity increases, the perceived value also increases. Yes? But the difference here is the amount of the perceived changes is not always the same as actual physical intensity changes. Okay. So if we look at, say, this as example, and the brightness. So if the brightness increase from 0 to 2, let's say increase by twice the amount, and you can see the perceived changes is only just slightly more than 1. It does not perceive as 2. Hope that makes sense. But if we look at this one, which is the lens, which is one of the good ones to represent the quantitative value or numerical, you can see it's actually perfect and 45-degree line. That means if the lens increase by 2 or double, and then you as a human look at the line, you think it's about twice the value as before. Yeah, and so this is probably the interesting one, which is the electrical shock. So that's you amount of the electricity you receive or the voltage you receive from the person to detect how much the value is. The more shocks you get or the higher the voltage, you will perceive more value. Obviously, this increase very quickly in the sense, if you increase the intensity by a little bit, for example, from 1 to 1.5, and then the shock people perceive is many, many times higher. So at 1, so this is something less than 1, so maybe 0.6 or something, and even just going to 1.5, which is somewhere here, what the people perceive is maybe the intensity is maybe 8 times bigger or 6, 7 times bigger than before.
All right, what does the 3.5 represent?
So that's just basically means the amount of changes or the amount of changes you perceive between this perceived changes and actual changes. So the perceived changes is about 3 times, 3.4 times, 3.55 times the actual change here on this side. Does that answer the question?
Yeah.
Yeah. So in terms of brightness.
Yeah. Sorry, Carl. Just just a bit of confusion there. You said the 3.5 actually represents the perceived sensation for electric shock. Yeah, but I mean, if I was to look at that plot, I would say, that it goes beyond 3.5.
Yes. So obviously, so for example, the electron shock is not a perfect straight line. And so the 3.5 is approximate value. It's not always correct along this line. But the important thing is, I think the main message is says, for the electronic shock, people perceive the changes is much bigger, a few times bigger than the actual increase.
Right. Okay.
Yeah. So in this case, it says it's 3.5 times the actual increase.
Okay.
Which is understandable. And so what it says for brightness, if you increase, if you double, people only can see or perceive through visually half. And then you can see for the lens, the amount of change people see visually is the same as the amount of actual changes in the lens. So that's why that makes it a good way to represent. Okay. Okay. And we're gonna do some tests now. Okay, and so first we're gonna do a saturation. So just basically means and amount of color. So if the value doubles, then I double the amount of color. And so I have these two blocks. So I use saturation to represent, or the blocks to represent certain value. So this is like the lighter one, and this is the darker one, represents bigger value. And I give you three options. So which one do you think that is? So do you think this one is maybe 1.5 times darker than this one, or twice, or 2.5 times? Which one would you pick? Can I have a show of hands? So someone thinks this is 1.5 times darker than the lighter one. Can you click yes now if you think that's the case? Okay, so no one thinks that. Okay, and anyone think that is maybe twice? Okay, I have two people, Chitu and Tommy. Oh, okay, so almost everyone thinks that's twice. And anyone think this is 2.5 times the color than this one? Okay, no one. Ah, okay, so that's actually correct. Ah, so okay, so in this experiment, we get a different conclusion. If you remember from here, actually, so it says people actually perceive more than the actual changes. So it's more than one, so it says 1.7. So I would expect actually more of you would pick 2.5 in this case. Okay, so let's do the next experiment. I'm gonna say, again, this time I'm using the lens. I have two lines. So longer the line, the larger the value. It's the same thing. So do you think the second line is 1.5 times the length of the first one, or twice, or 2.5 times? So, okay, and everyone think this is 1.5 times? Can you press yes now? Okay, no one thinks that's 1.5 times. And if you think it's twice, press the yes now. Oh, only two people think it's twice, or three. Any more? No. Okay. Anyone thinks that's 2.5 times? Okay, Liv and York, and the Roya. And so the correct answer is twice. Okay. I mean, this is, I guess, because it's not in the lecture room, it's difficult. But if you can measure, it's quite easy. Should be quite easy to see. But if this is a half, that's roughly twice the size. Okay, and I have one last test. And so in this case, I'm going to use size, the area of the square to represent value. And then again, the same choice. So for this one, is that 1.5 times, or twice, or 2.5 times area of this first one? Okay, so if people think it's 1.5 times, please click yes now. Oh, really? Oh, okay. One people. G2. And anyone think that's twice the size? The second one is twice the size of the first one. Okay, I have, okay. A majority of people pick the 2. Okay, and anyone thinks that's 2.5 times. So this is 2.5 times the area of this one. Okay, so no one thinks. Yeah, again, the correct answer is 2. So actually, I was expecting more people would select the first option, because according to this one, most people would underestimate how much change that is. So if there's, say, change by 1 in the actual value, people might perceive 0.7 in the actual. Okay, and that was quite interesting. So certainly quite different results compared to what I did before. Okay. Yeah, and I think we'll stop there today. I will stop there now. We're kind of close to the end, so I want to step. We certainly haven't finished all the slides for today, and we're gonna do that. Continue.
Just quick question before we go. Are we, with the questions, are we basing the answers on our perception on how we look at the squares or the areas or the lines?
Yes. And so, for example, say the last one, you look at these 2 squares, and you just estimate how bigger the second one compared to the first one, just visually. If you, that's all. Yeah.
Okay. All right.
I'm quite surprised. I mean, we've got lots of correct answers today, and actually less so for the lens. So the lens is actually meant to be the accurate one. So your visual estimation will be very similar to the actual difference between the value. Okay. And okay. Is there any other question before we finish today? Okay.
No, no, thank you.
Okay.
Yeah, thank you.
And I'll see you later at the lab then.
Sure.
Yeah.
Okay. Yeah. Really. Thank you.
Okay.
Thank you.
Bye.